Hello, welcome to my YouTube channel Code with Srividya. In this series, I am going to talk about all the DSA concepts like arrays, linked list, stack, queue, recursion, trees, divide and conquer approach, greedy programming and dynamic programming. In the very first video, I am going to talk about one-dimensional and two-dimensional arrays. Here in the video, you can see the real-life examples of arrays. Here you can find out the apps in the phone are arranged sequentially. The cells in the chessboard are arranged sequentially and the chocolate blocks. So these are all the real life examples of arrays. In the next slide you can see the example of egg tray. So this is an example of two-dimensional array. You can see we can only store eggs in this tray. That depicts we can store similar type of elements in the arrays. So these eggs are next to each other. That means they are sequentially arranged same like arrays. Each egg can be uniquely identified with their location. So we can use the index I and j in the two-dimensional arrays and locate the array. You can see a single dimension array. So an array can store specific type of elements. Here it is storing integer elements. You cannot store a string into this array. These elements are contiguously located in the memory. That means next to each other. Each element has a unique index with which we can identify each element, and the size of the array is predefined and we cannot modify the array. In computer science, the definition of the array is it is a collection of elements each identified by at least one array index, and the index is mathematically computed. That means sequentially 0, 1, 2, 3 and so on. You can have a question, why do we need array? For storing 3 numbers, maybe it is easy to create 3 variables. But if at all we want to store 500 elements, is it best option to create 500 elements? It's wrong. So we create an array. So the arrays are of two types, one-dimensional and multi-dimensional. In multi-dimensional we have two-dimensional, three-dimensional and so on. So here you can see the single dimension array example. So we have only single index here which starts from 0 to length minus 1. In the two-dimensional array, we have two indexes I and j which start from 0 to rows minus 1 and j starts from 0 to columns minus 1. So this is example of the three-dimensional array. You can take example of a cube. In this we have three indexes x, y and z, or else you can call them first index, second index and third index. So let us understand how the arrays are stored in the memory, in RAM memory. So you can see a one-dimension array here and the memory is continuously allocated in the RAM. That means if we create an array of size 5, in the future we cannot change the size because we may have some other things stored in the next space. You can see, you may wonder if you understand like how the multi-dimensional is stored in the memory. It is not stored like the box. It is also sequentially stored, but we have references to the array like I and j indexes which helps us to identify or easily access the multi-dimensional arrays. So when we declare an array, the reference is stored in the stack, but it is not creating the array or it is not allocating the space in the heap as soon as we declare. Only when we instantiate the array, it creates the space in the heap. And when we initialize the values, that means when we assign the values to the cell, it assigns the values in their respective region. So you can see the syntax to declare an array, the data type and the square brackets and the array name. And next you can see how to instantiate an array. Array equal to new data type and the size. This way we give the initialization, we assign the values. So you can see declaration, instantiation and initialization of the array. You can do all these things in the single step, like int array equal to 1, 2, 3. So now let us understand how to do insertion in the array. We use the name of the array and the index equal to the element we want to assign. So in order to insert in the beginning of the array, see here you can see an example. If you want to insert -3 in the beginning, you have to move all the elements to the next space. So let us start